It was the morning of October 29th, 2025, to be exact. The clock showed 11:47 Universal Time when it happened. Something we couldn't witness with our own eyes. 3I Atlas, that mysterious interstellar traveler that's had astronomers buzzing since July, reached its closest approach to our sun, perihelion, just 203 million kilometers of empty space between them. And here's the twist. For the first and only time during its journey through our solar system, Earth lost sight of it completely, hidden behind our star like a poker player clutching their cards tight. Most comets, they're predictable, slaves to gravity's relentless pull, their paths mapped out to the millisecond. But what if this one's playing by different rules? What if those hours when we couldn't watch? That perfect blind spot when not a single telescope on Earth or orbiting above could track its movements. What if 3I Atlas did something that regular comets simply can't do? What if it changed course? Not some gradual drift, not a subtle nudge, but a deliberate, calculated maneuver. Using the sun's gravitational pull like nature's own catapult, launching probes, maybe dozens of them, toward the inner planets, toward us. The Oberth maneuver. That's what we call it when our own spacecraft need maximum efficiency. Fire your engines at perihelion, at your point of highest speed, and you get incredible bang for your buck. Avi warned us to watch for exactly this scenario. He said if 3I Atlas turned out to be anything other than a natural comet, yesterday would be the day it showed its hand. And now it's November, and our telescopes are straining to find it again. Some are picking up signals that don't match predictions, trajectories that have shifted, objects that weren't there before. This isn't a drill anymore. This isn't wild speculation. This is what happens when a 7-billion-year-old visitor from the direction of Sagittarius, from the galactic center itself, decides Earth deserves a closer look. If you're hooked on this deep dive, smash that like button and subscribe. It genuinely helps us keep bringing you these cosmic mysteries. Drop a comment, tell me where you're tuning in from, what time it is there, and what you really think 3I Atlas is. Natural wonder or something far stranger? Share this video and hit that notification bell if you want to help our community grow. Thank you for being here. Disclaimer: this is a fictional scenario grounded in real science and actual data about 3I Atlas. The actual interstellar object followed its predicted path and poses zero threat to Earth. What you're about to hear is speculative entertainment, a big what if. Now, let's rewind. 11:47 Universal Time, October 29th. The European Space Agency's JUICE spacecraft, the Jupiter Icy Moons Explorer, happened to be the closest human-made object with a decent view, just 64 million kilometers away. Still a huge distance by any normal measure, but in cosmic terms, practically neighbors. JUICE wasn't built to study comets. Its mission targets Jupiter's moons, Ganymede, Europa, Callisto, hunting for subsurface oceans and potentially habitable environments. But on October 29th, mission controllers made a call. They temporarily redirected its instruments. They wanted something. Any data from perihelion, some record of what 3I Atlas looked like at peak solar heating. The first data packets arrived 11 hours later. Standard telemetry, compressed images, spectroscopic readings. The science team in Darmstadt, Germany worked through the night processing them. That's when they spotted it, the anomaly. 3I Atlas was brighter than predicted, not by a little, by almost a full magnitude. Now, comets can surprise you with brightness spikes. Outgassing can surge unpredictably when volatile ices sublimate under solar bombardment. Carbon dioxide, carbon monoxide, water, all transforming from solid to gas in minutes, creating those gorgeous tails and glowing halos we associate with comets. The models predicted 3I Atlas would hit magnitude 11.5 at perihelion. JUICE's readings, magnitude 10.1, that's 2.5 times brighter. But brightness alone wasn't the red flag, it was the pattern. The glow around 3I Atlas wasn't symmetrical. Natural comets develop roughly spherical halos, maybe stretched into teardrops by solar wind, but generally centered on the nucleus. What JUICE captured looked different. Multiple bright spots, 7 distinct glowing regions arranged around the central body, each exhibiting its own spectral signature, its own emission pattern. And here's where it gets really weird. The JUICE data showed motion. Relative motion. Between the start of JUICE's observation sequence and the end, just 42 minutes later, those bright spots had moved. Not in the expected direction, not following the ballistic trajectory you'd expect from ejected debris. They were spreading out, diverging, and some of them were accelerating. Think about that for a second. Natural processes don't accelerate in a vacuum. When you eject material from a comet, it follows Newton's laws. It coasts. Solar wind might push it, radiation pressure might nudge it, but those forces don't cause sudden accelerations hours after the initial outburst. Yet here were 7 objects, each roughly school bus-sized based on brightness and distance, exhibiting velocity changes that screamed active propulsion. The initial report was classified within hours, not hidden, not covered up, but restricted to the International Asteroid Warning Network, IAWN, the group coordinating global response to potentially hazardous space objects. By evening on October 29th, 36 observatories across 4 continents had been alerted. Emergency observation protocols activated. Every telescope capable of slewing toward the solar region, every instrument that could detect near-Sun objects was reassigned. That's when the second wave of anomalies hit. NASA's Parker Solar Probe was in the neighborhood, not close enough to image 3I Atlas directly, but perfectly positioned to detect radio emissions, plasma interactions, unusual magnetic field disturbances. Parker's instruments recorded a series of structured radio bursts coinciding with perihelion passage, frequencies centered around 1.42 gigahertz. That's the hydrogen line. The so-called universal frequency, the wavelength hydrogen atoms emit naturally, it's the frequency SETI researchers have monitored for decades because any technological civilization would recognize its significance. The Parker data showed pulses, not random noise, not sporadic emissions from natural plasma interactions. These were rhythmic, patterned, repeating in intervals following a sequence. 3 seconds, then 5, then 8, then 13, then 21. Each pulse lasting exactly as long as its number indicated, and the pattern continued. 34 seconds, 55 seconds, 89 seconds. Some of you are already seeing it. That's the Fibonacci sequence. Each number equals the sum of the 2 before it. One of the most famous mathematical patterns in nature, appearing in flower petals, spiral galaxies, rabbit breeding patterns. It's a pattern that screams order, that announces mathematical awareness, and it was coming from 3I Atlas's direction, at the exact moment of perihelion. Let's be crystal clear about what this means. The Fibonacci sequence doesn't appear spontaneously in radio emissions. Solar flares don't count to 34. Plasma interactions don't solve addition problems. Natural processes can create patterns, absolutely, but not mathematical sequences requiring memory, requiring each emission to know what came before and calculate what comes next. This is information theory. This is signal structure implying intent. The Parker data was flagged for immediate review. By midnight Central European Time, copies had been forwarded to the SETI Institute, to the Galileo Project, to Harvard's astronomy department, where Avi and his team were already awake, already analyzing. By dawn on October 30th, the astronomical community was in controlled chaos. Not panic. Scientists don't do panic, but intense, focused urgency. The kind you see when something extraordinary demands immediate attention, and every hour of delay means lost data, missed opportunities. Avi Loeb's team at Harvard became the unofficial coordination center, not by official designation, but through reputation and expertise. When you've spent years arguing that we should take interstellar objects seriously as potential probes, and then one actually behaves like a probe, people listen. The first challenge: confirm the observations. JUICE's data was solid, but it came from a single spacecraft with instruments not optimized for comet observation. Parker's radio data was intriguing, but radio astronomy has a million ways to generate false positives. Before anyone could make definitive claims, independent confirmation was essential. Ground-based observatories faced a problem. 3i Atlas was still too close to the Sun. Solar glare made observation nearly impossible from Earth's surface. But there were workarounds. Space-based telescopes, observatories at extreme latitudes where seasonal angles provided better solar separation, and specialized solar observatories designed to block the sun's direct light while imaging the surrounding corona. The Solar and Heliospheric Observatory, SOHO, was first to provide corroboration. Its coronagraph instruments, designed to study the sun's outer atmosphere, captured images of 3i Atlas emerging from perihelion, and there they were. Multiple objects in the vicinity of the main body. Distinct points of light, too bright to be simple debris, exhibiting independent motion. SOHO's images weren't high resolution enough to reveal details, but they confirmed the basic reality. Something had separated from 3i Atlas. Multiple somethings. And they weren't behaving like natural ejecta. The Stratospheric Observatory for Infrared Astronomy, SOFIA, a modified Boeing 747 carrying a telescope above most of Earth's atmosphere, conducted emergency flights. Flying at 45,000 feet, above 99% of atmospheric water vapor, SOFIA could observe infrared wavelengths blocked at ground level. Its October 30th observations detected thermal emissions from the separated objects, temperature signatures inconsistent with bare rock or ice. Instead, the objects showed thermal profiles suggesting active temperature regulation, hot spots and cool spots, in patterns that natural objects exposed to solar radiation simply don't exhibit. By October 31st, Halloween, the data was compelling enough that NASA convened an emergency press conference, not to announce alien contact, that would be premature, but to acknowledge the anomalous observations and outline the observational campaign being organized. The press conference was carefully worded. Dr. Sarah Mitchell, NASA's chief scientist for planetary defense, presented the facts without speculation. Yes, 3i Atlas had exhibited unexpected behavior at perihelion. Yes, multiple objects had apparently separated from the main body. Yes, radio emissions with structured patterns had been detected. No, none of this definitively proved non-natural origin. Yes, all possibilities remained under investigation. The media, predictably, went wild. Within hours, alien probe was trending globally. Every news outlet, every social media platform, every podcast and YouTube channel was discussing the implications. Conspiracy theorists had a field day, weaving elaborate narratives about government cover-ups and secret alien communications. Religious groups debated theological implications. Stock markets wobbled as investors grappled with uncertainty about potential paradigm shifts. The scientific community tried to maintain perspective. Many researchers urged caution, noting that unusual doesn't equal alien, that nature can surprise us in countless ways, that extraordinary claims require extraordinary evidence. The principle applies. When you hear hoofbeats, think horses, not zebras. Or in this case, think unusual natural phenomena before jumping to interstellar visitors. But the counterargument was equally valid. When the horse exhibits behavior horses don't exhibit, maybe it's time to consider zebras, or unicorns, or something entirely outside our expected categories. Avi Loeb published a brief paper on Archive, the preprint server where physicists share research before peer review. His argument was characteristically direct. The observations matched predictions for what an intelligent probe might do at perihelion. The Oberth maneuver, the timing, the multiple separated objects, all consistent with a mothership deploying smaller probes for closer planetary investigation. The Fibonacci sequence radio bursts suggested intentional signaling, perhaps an attempt at communication, or simply a beacon identifying the objects as artificial. The paper generated immediate controversy. Some colleagues praised Avi's willingness to consider unconventional explanations. Others criticized him for premature speculation, for elevating hypotheses without sufficient elimination of natural alternatives. The debate played out in academic journals, on Twitter, in heated email exchanges and tense departmental meetings. Meanwhile, the tracking effort intensified. With 3i Atlas moving away from the Sun, observation windows improved for ground-based telescopes. Major observatories, Keck in Hawaii, the Very Large Telescope in Chile, the Gemini telescopes, all devoted time to tracking the separated objects and refining their orbital parameters. The data that emerged over the next week painted a disturbing picture. The 7 objects weren't following ballistic trajectories. Natural debris ejected from a comet follows predictable paths determined entirely by initial velocity and gravitational influences. These objects were showing course corrections, small but measurable trajectory adjustments that required thrust, required propulsion, required control. 3 of the objects were heading inward toward Earth and Venus. 2 were angling toward Mars. 1 appeared targeted at the asteroid belt. The 7th was on a trajectory toward Jupiter's moons, almost as if coordinating with the mothership's eventual destination. The implications were staggering. If these were probes, and the evidence was mounting, they represented a reconnaissance mission of extraordinary scope. Not just Earth, but multiple planets and moons across the inner and outer solar system. A comprehensive survey of our cosmic neighborhood by visitors from interstellar space. Governments began closed-door discussions about response protocols. The UN Office for Outer Space Affairs convened emergency sessions. Military strategists wargamed scenarios. What if the probes were hostile? What if they were merely observational? What if they attempted communication? What if they approached Earth's orbit? Did humanity have any capability to intercept, to defend, to respond? The uncomfortable answer, not really. Our space capabilities, impressive by historical standards, looked pathetic when considering defense against objects exhibiting advanced propulsion. We had no weapon systems designed for space combat, no missiles that could effectively target objects with unpredictable trajectories, no defense networks capable of protecting against threats from above. Some politicians advocated for aggressive postures. If the probes entered certain proximity thresholds, they should be destroyed as potential threats. Others counseled patience and scientific observation. Attacking objects that might be peaceful explorers could trigger the very hostility we feared. It could brand humanity as barbaric, paranoid, unworthy of contact. The debate raged while the probes continued their journeys, indifferent to human arguments about their nature and intent. By mid-November, trajectory predictions had refined significantly. The three probes heading toward the inner solar system, designated Probe 1, Probe 2, and Probe 3 by the International Astronomical Union, would reach their closest Earth approaches in December. Probe 1 was tracking for a flyby on December 19th, passing within approximately 9 million kilometers of Earth. That sounds like a vast distance, and it is, roughly 23 times the Earth-Moon distance, but in astronomical terms, it's a hair's breadth, a near approach. Within the Moon's orbit around Earth, close enough for detailed observation, close enough to make people nervous. Probe 2 would follow roughly 38 hours later, December 20th, on a trajectory passing about 11 million kilometers from Earth. Its path suggested a Venus flyby first, then an Earth approach, like a tourist hitting multiple destinations on the same trip. Probe 3 was harder to pin down. Its orbit showed more variability, more frequent course corrections. Estimates placed its Earth approach somewhere between December 18th and 20th, but the uncertainty window remained frustratingly large. It was the wild card, the least predictable of the three. The probes heading to Mars wouldn't arrive until February and March 2026. The asteroid belt probe was months away from its presumed destination. The Jupiter-bound probe wouldn't reach its target until late March, roughly coinciding with 3i Atlas's own Jupiter flyby. Those were longer-term concerns. December's approaches demanded immediate attention. Observatories worldwide coordinated observation schedules. The goal? Continuous coverage. No gaps where probes might perform actions unobserved. Radio telescopes listened constantly for any transmissions. Radar facilities bounced signals trying to measure size, shape, reflectivity, any properties that might reveal the object's nature. The probes weren't making it easy. They were small. Estimates suggested roughly 2 to 3 meters in diameter, though that calculation involved significant uncertainty. They were dark, reflecting very little sunlight. They were detectable primarily through their thermal emissions, the heat they radiated in infrared wavelengths. But even that signature was peculiar. Natural objects in space radiate heat according to well-understood physics. Sunlight heats the day side. That heat slowly distributes across the surface and radiates into space. You get predictable temperature patterns, hot on the sun-facing side, cooler on the shadowed side, with gradients depending on rotation rate and thermal conductivity. The probes showed something different. Their thermal signatures suggested active temperature control. The sun-facing sides weren't as hot as they should be. The shadowed sides weren't as cold. The temperature distribution suggested insulation, heat management, possibly active cooling systems. These were characteristics of engineered objects, not natural rocks. Spectroscopic analysis provided additional clues. When you analyze light reflected or emitted by an object, you can identify its composition. Different elements and compounds absorb and emit specific wavelengths, creating distinctive spectral fingerprints. The probe's spectra were weird. They showed features that didn't match any common solar system materials. Not iron-nickel like metal asteroids, not silicate rock like stony asteroids, not water-ice like comets. There were absorption features suggesting carbon compounds, possibly organics, possibly polymers, possibly engineered materials designed for specific optical properties. Some researchers suggested the probes might be covered in something like vantablack, the ultra-dark material that absorbs 99.96% of visible light. That would explain why they were so hard to see, despite being relatively large. It would also suggest deliberate design for stealth, for minimizing detectability. By late November, public awareness had settled into a strange equilibrium. Yes, mysterious objects were approaching Earth. Yes, they might be alien probes. But there were no immediate threats, no visible changes to daily life. People went to work, shopped for groceries, argued about politics, watched entertainment. Life continued, with an asterisk. A background awareness that reality might be about to shift in fundamental ways. News coverage remained intense, but no longer dominated every headline. The initial shock had worn off. Humanity was demonstrating its remarkable capacity for normalizing the extraordinary. Alien probes? Sure. Let me know when they actually do something interesting. Meanwhile, I have bills to pay. Scientists didn't have the luxury of normalization. For them, the pressure intensified as December approached. This might be a once-in-a-lifetime opportunity, or a once-in-civilization opportunity. Whatever these objects were, the close approaches in December would provide unprecedented observation windows. Missing data now might mean losing information forever. Planning intensified for the December observation campaign. Every major telescope facility had blocked out time. Space agencies coordinated spacecraft observations. Military installations readied classified assets, satellites and sensors whose capabilities remained secret but were presumably being brought to bear on the approaching probes. Amateur astronomers got involved too. While the probes were too faint for backyard telescopes, coordinated networks of amateur observers could contribute. Meteor camera networks, satellite tracking stations, even sophisticated amateur radio operators monitoring for any unusual signals. The distributed nature of observation meant that even if clouds blocked one location or equipment failed at another, someone somewhere would likely capture critical data. December 1st marked the beginning of intensive countdown coverage. News organizations launched daily update segments. Websites created countdown timers. Social media filled with speculation, fear, excitement, memes. Some people planned viewing parties. Others stocked emergency supplies. A few quit their jobs, declaring that if aliens were arriving, mundane employment seemed pointless. Religious responses varied widely. Some saw the probes as divine messengers, angels or signs from God heralding a new age. Others viewed them as demonic, tests of faith or harbingers of apocalypse. Most religious leaders urged calm and faith, reminding their communities that whatever was happening, fundamental spiritual truths remained unchanged. Philosophers and ethicists published essays on first contact protocols. If the probes were indeed artificial, if they represented another intelligence, how should humanity respond? Should we attempt communication? What would we say? Who gets to speak for Earth? The UN? NASA? Elected governments? Scientists? Or should we remain silent, observing but not revealing ourselves? That last option was already moot. If these were probes, they obviously knew we were here. They'd deliberately come to our solar system, adjusted trajectories toward our planet. We'd been detected. The question wasn't whether to hide, too late for that, but how to respond to visitors who'd already found us. Some advocated for active transmission, using radio telescopes to beam messages at the approaching probes. Mathematical sequences, images, cultural information. Let them know we're intelligent, that we recognize them as artificial, that we're attempting peaceful communication. Others vehemently opposed active messaging. METI, messaging to extraterrestrial intelligence, was controversial even before suspected alien probes entered the solar system. Critics argued that announcing our presence to unknown intelligences was reckless, that we had no idea of their intentions or capabilities, that prudence demanded caution. The debate became moot when several institutions independently began transmitting. China's FAST telescope, the world's largest single-dish radio telescope, broadcast a message toward Probe 1's trajectory. The message included prime numbers, the periodic table, images of Earth and human beings, and audio samples of music and speech. The Arecibo telescope in Puerto Rico, repaired after its 2020 collapse specifically for this purpose, transmitted similar content toward Probe 2. Private organizations got involved too. METI International, a controversial group dedicated to active messaging, coordinated transmissions from multiple facilities toward all three probes. Whether the probes received, understood, or cared about these messages remained unknown. They continued their approaches without obvious response. No return transmissions, no course changes acknowledging the communications, no signs of recognition. Just silent, steady progress toward their destinations. By December 10th, the probes were close enough that optical telescopes could capture more than just points of light. The images weren't sharp, still just fuzzy blobs, but enough to estimate size and shape. The objects appeared roughly spherical, perhaps slightly elongated. Smooth surfaces without obvious features like antennas or ports. Dark, absorbing rather than reflecting light. They looked designed. That was the unanimous impression from observers. Natural asteroids are irregular, all lumps and craters and rough surfaces. These were smooth. Even without seeing details, the overall impression was of manufactured objects, things built with purpose and planning. The data piled up. Trajectory analyses, spectroscopic measurements, radar returns, thermal imaging, radio monitoring. Every conceivable sensor and technique applied to extracting information from the approaching objects. And all of it pointed toward the same conclusion. These were not natural. These were artificial. These were probes. The only remaining question was intent, reconnaissance, communication, threat assessment, or something else entirely, something human minds couldn't anticipate because it arose from alien logic and alien priorities. December 18th would be the beginning of answers, or perhaps the beginning of entirely new questions. December 10th arrived with a strange cocktail of anticipation and dread. The world had 9 days left before the first probe reached its closest approach. 9 days to prepare for what exactly? That was the question nobody could answer with confidence. Global governments coordinated through back channels that had been quietly established in November. The UN Security Council held daily briefings, though most substantive discussions happened in classified sessions closed to public and press. The official narrative emphasized observation and scientific study. The unofficial reality involved military contingencies that ranged from optimistic to apocalyptic. The United States Space Force, established just years earlier and still finding its footing as a military branch, suddenly found itself thrust into relevance. Assets that had been launched for satellite defense and space domain awareness were now potentially humanity's first line of response if the probes turned hostile. Not that anyone had illusions about effectiveness. You can't shoot down objects exhibiting propulsion capabilities beyond known physics. But having something felt better than having nothing. Russia coordinated with former adversaries in ways that would have seemed impossible months earlier. China shared tracking data openly, abandoning its usual secrecy about military space capabilities. The European Space Agency, Japan's JAXA, India's ISRO, all contributing resources and expertise to the collaborative observation effort. Old rivalries didn't disappear, but they got temporarily shelved in face of shared uncertainty. The scientific community worked around the clock. Sleep became optional. Coffee consumption reached levels that would alarm medical professionals. Research teams operated in shifts, ensuring continuous analysis as new data flowed in from observatories worldwide. Every photon captured from the approaching probes got analyzed, cataloged, cross-referenced with theories and models attempting to predict behavior. Avi Loeb's team at Harvard became an informal clearinghouse for data integration. His earlier warnings about 3I Atlas, his willingness to consider artificial origin when others dismissed the possibility, gave him credibility that translated into coordination authority. Researchers from dozens of institutions shared findings with his group, knowing they'd get synthesized into coherent analysis rather than buried in competing interpretations. The trajectory refinements coming in daily showed something both fascinating and unsettling. The probes were adjusting their approaches with precision that suggested active guidance. Small course corrections timed perfectly to optimize their Earth flybys for maximum observation potential while maintaining safe distances. Safe by whose standards remained unclear. 9 million kilometers was safe by some definitions, terrifyingly close by others. Probe 3, the wild card, continued exhibiting the most dynamic behavior. Its trajectory shifted more frequently than the others, leading to speculation that it might be the most sophisticated of the group, possibly the mission's primary reconnaissance asset, while probes 1 and 2 served as backups or as specialized observers. By December 12th, all 3 probes were visible to serious amateur astronomers with good equipment and dark skies. Still faint, magnitude 12 to 13, requiring at least 6-inch telescopes and patient observation, but detectable. This democratization of observation created thousands of additional data points. Amateur networks, coordinated through online forums and social media, contributed tracking data that helped fill gaps in professional coverage. The internet exploded with images, videos, and speculation. Every blurry photograph got analyzed and reanalyzed. Some people claimed to see details in the images, structures, lights, symbols. Most of these were pareidolia, the human tendency to see patterns in random visual noise. But sorting genuine anomalies from wishful thinking and outright fabrications became a full-time job for fact-checkers and analysis teams. Misinformation spread as fast as legitimate data. Fake videos showing probes performing impossible maneuvers went viral. Conspiracy theorists connected the probes to everything from ancient astronaut theories to secret government programs to religious prophecy. Debunking false claims consumed resources that scientists would rather have devoted to actual research, but leaving misinformation unchallenged seemed worse. December 15th brought the first genuine surprise since perihelion. Probe 1, now just 4 days from closest approach, emitted a brief radio burst, lasting only 2.7 seconds, centered at 1.42 gigahertz, the hydrogen line again. The same frequency as the Fibonacci sequence detected by Parker's solar probe back in October. But this wasn't a mathematical pattern. This was structured differently. Data. Information encoded in the carrier wave through frequency modulation. The signal carried approximately 200 kilobits of information, downloaded in less than 3 seconds, at a transmission rate that suggested sophisticated communications technology. The data was encrypted, or at least incomprehensible. Researchers ran every decryption algorithm available, tried every known encoding scheme, applied pattern recognition software and AI analysis tools. Nothing produced obvious meaning. The data might be a message humanity simply couldn't decode without some kind of key or primer. Or it might be telemetry, the probe reporting its status to some distant receiver. Or internal systems communication accidentally leaked into space. What was clear, the burst wasn't natural. Natural radio sources don't produce time-limited, frequency-modulated transmissions with data structures suggesting intentional information encoding. This was technology, artificial, purposeful. The detection sparked fierce debate about response. Should humanity transmit back? If yes, what should we say? Mathematical acknowledgement that we'd received the signal? Attempt at establishing communication protocols? Or maintain silence, observing without revealing our own capabilities and intentions? The debate became academic when the Chinese Fast Telescope transmitted a response 8 hours after the burst detection. A simple mathematical sequence, prime numbers counting up from 2 to 97, followed by a reproduction of the received signal, then another prime sequence. The message? We heard you. We recognize this as information. We're intelligent. We can communicate. Other facilities followed suit. Within 24 hours, at least 6 major radio telescopes had transmitted toward Probe 1. Some sent duplicates of China's message. Others tried different approaches: visual data, audio samples, binary representations of physical constants. A scattered, uncoordinated first impression from a species still figuring out how to present itself. Probe 1 didn't respond, at least not detectably. It continued its approach without further transmissions, without course changes, acknowledging the multiple messages now racing toward it through space. December 16th, 17th. Time compressed. Hours felt like minutes, while simultaneously dragging like weeks. News coverage shifted into countdown mode. Every major network ran special programming. Streaming services offered live feeds from observatories. People who'd never looked at the night sky started downloading stargazing apps and trying to spot the probes. Weather became a topic of obsessive discussion. Cloud forecasts for December 18th, 19th. Would skies be clear? Would observers get unobstructed views during the critical approach windows? Meteorologists found themselves fielding more questions about astronomical observing conditions than about daily weather forecasts. Schools incorporated the approaching probes into curriculum. Science classes tracked trajectories, calculated distances, discussed orbital mechanics. History teachers led discussions about historical first contacts between civilizations, Columbus and Native Americans, Europeans and Pacific Islanders, and the often tragic consequences of encounters between peoples with vastly different technological capabilities. Those discussions raised uncomfortable questions. In every historical first contact on Earth, the more technologically advanced civilization dominated, sometimes through violence, sometimes through disease, sometimes through economic and cultural overwhelming. If the probes represented a more advanced intelligence, what did history suggest about humanity's prospects? Some took comfort in the fact that genuinely advanced civilizations might have grown beyond the imperial violence that characterized human history. Maybe intelligence, given enough time, naturally evolves toward peace and cooperation. Maybe any species capable of interstellar travel had necessarily solved problems of internal conflict and developed ethical frameworks valuing all life. Others found that optimism naive. Violence and competition drove much of evolutionary history. Intelligence arose as an advantage in resource competition. Advanced technology meant advanced weapons. The probes might belong to species that viewed other intelligences as threats or resources rather than partners. Nobody knew. That was the terrifying, exhilarating reality. We were about to meet the other, and centuries of science fiction hadn't adequately prepared humanity for the actual experience. December 17th, evening. 24 hours before Probe 1's closest approach. The world held its breath. Markets closed early, though trading would be suspended for the critical period regardless. Governments issued reassurances. There was no imminent threat. Life should continue normally. Emergency services remained operational, but normal had already departed. Streets were quieter than usual for mid-December. Many people stayed home, glued to screens showing countdown timers and live telescope feeds. Others gathered in public spaces, at planetariums and science centers, at churches and community centers, seeking community, shared experience, comfort in numbers during uncertainty. Religious services around the world addressed the probes directly, prayers for peace, for wisdom, for divine guidance. Some religious leaders admitted they didn't know what to make of events, that their traditions hadn't prepared them for possible intelligent life beyond Earth. Others confidently interpreted everything through theological frameworks, seeing divine will or eschatological fulfillment in the approaching objects. The Pope issued a statement acknowledging that if the probes represented alien intelligence, such beings would also be God's creation, loved by their Creator as humanity was loved. The statement emphasized that Christian love and welcome should extend to all God's children, wherever they originated. Other religious leaders issued similar messages, though interpretations varied on whether the probes represented blessed encounter or ultimate test. Scientists tried to manage expectations. Dr. Mitchell from NASA did multiple interviews emphasizing that the flybys might reveal nothing dramatic. The probes might pass silently, collecting data but offering no communication, no revelation, no transformation. We might learn little more than we already knew. The approach could be anticlimactic. But nobody believed that. Something in the air, some collective intuition suggested December 18th and 19th would matter, would change things, would mark a before and after in human experience. Midnight approached, transitioning December 17th to 18th. In time zones ahead of UTC, it was already the 18th, already the day. People in Asia and Australia were already living the moment that Americans and Europeans still anticipated. The strangeness of global simultaneity became apparent. We talk about events happening now, but now is different depending on longitude. The probe approaches didn't care about time zones, happened according to orbital mechanics and celestial geometry, regardless of whether human clocks showed morning or midnight. 3:22 a.m. Universal Time, December 19th. That was closest approach for Probe 1. For someone in London, that's 3:22 a.m. local time. For New York, 10:22 p.m. on December 18th. For Tokyo, 12:22 p.m. on the 19th. Same event, different calendars, different daily contexts. Some people would be sleeping, some working, some eating lunch when it happened. Observatories didn't sleep. Every telescope that could track Probe 1 was locked on target, cameras recording continuously, spectrographs analyzing every wavelength, radar pulses bouncing off the approaching object, measuring distance with centimeter precision, radio telescopes listening across the spectrum for any transmission. The data rate from observatories to analysis centers exceeded anything attempted before. Specialized fiber optic lines carried terabytes per hour. Dedicated data centers struggled to process the incoming flood. Machine learning algorithms ran in real time, flagging potential anomalies for human review. Still, much of the analysis would happen later. Right now, the priority was capture everything, analyze later, don't miss anything. Amateur observers took up positions. Those with equipment gathered at dark sky sites, away from city lights. Those without telescopes simply looked up, aware they couldn't see the probe, but wanting to witness the sky at this historic moment. Social media filled with photos of people staring upward, of gathered crowds, of faces illuminated by screen glow showing tracking data and countdown timers. 6 hours to closest approach, then 5. Then 4. The tension was unbearable and impossible to escape. Even people trying to ignore events found themselves checking news feeds, glancing at countdown timers, unable to focus on anything else. Productivity worldwide plummeted to near zero. This was humanity's collective holding of breath. 3 hours before closest approach, Probe 1 made its second transmission. Brief, 3 seconds. Same frequency as before. But this time the data structure was different, simpler, more repetitive. Pattern analysts recognized it immediately as a potential primer, a key for decoding the earlier transmission. The primer was elegant. It started with physical constants expressed in binary: the speed of light in vacuum, Planck's constant, the electron's charge, universal values any technological civilization would know. Then it showed how these constants could be used to establish units of measurement: length, time, mass, basic mathematical operations, logic gates, the foundations of information encoding. Within 90 minutes, 3 independent teams had used the primer to partially decode the first transmission. The message wasn't language, wasn't symbolic communication in the human sense. It was data, pure information, specifications. The probe was describing itself. Its dimensions: 2.7 meters diameter, oblate spheroid shape, mass approximately 340 kilograms, power source: radioisotope thermoelectric generator using elements not found in Earth's periodic table, either from neutron star matter or created through processes we didn't understand. Propulsion: something involving field manipulation, possibly electromagnetic, but in configurations that violated conventional physics. More importantly, it described its sensors: optical systems spanning ultraviolet through far infrared, radar in multiple bands, particle detectors sensitive to energetic radiation, magnetometers, gravimeters, chemical sniffers capable of analyzing atmospheric composition from millions of kilometers away. And it described its mission parameters: observation, analysis, data collection. It was studying Earth, specifically studying Earth's biosphere, its technological signatures, its atmospheric composition, looking for markers of life and intelligence, confirming what it already suspected based on observations from interstellar space. The transmission included something else: coordinates. Not just Probe 1's trajectory, but the trajectories of all 7 probes deployed from 3i Atlas, their destinations throughout the solar system, their observation targets. This was reconnaissance mission profile, being shared openly as if the probe wanted us to understand its intentions. Was this transparency meant to be reassuring? Or was it the confidence of power, the lack of concern about revealing capabilities because concealment was unnecessary? The probe was essentially saying, "This is what we're doing, this is how we're doing it, we're not hiding from you." 1 hour to closest approach, observatories reported Probe 1 was performing as predicted. No sudden maneuvers, no threatening behavior, just steady approach along the calculated trajectory. Whatever happened next would happen at 8.6 million kilometers distance. Close by cosmic standards, but still far enough that no immediate physical interaction was possible. Radio astronomers reported something peculiar. The background radio noise from Probe 1's direction had changed character. Still subtle, still at the edge of detectability, but there was structured activity in the EM spectrum. Not transmissions aimed at Earth, but rather like overhearing someone's internal systems hum. The probe was active, sensors operating, systems processing information, perhaps transmitting data somewhere to some distant receiver light years away. 30 minutes. News anchors struggled to fill airtime. What more could be said? The probe was approaching, would reach closest point in half an hour, then recede. Unless it did something unexpected, this might be the ultimate anticlimax. All this build-up for an object that passed by silently, collected data, and departed. But the tension remained. Anything could still happen. 15 minutes. Amateur photographers with telephoto lenses captured streaks as the probe moved against background stars, moving fast now, its orbital velocity relative to Earth substantial at this distance. The streaks were just light trails, no details visible, but they were real, tangible proof of the probe's existence for people who'd followed this story for months. 10 minutes. Some observatories lost tracking temporarily as Probe 1 passed through regions of space with specific magnetic field configurations. The probe seemed to interact with Earth's extended magnetosphere in ways that briefly scattered radar returns and confused tracking software. Teams scrambled to reacquire lock, hearts racing, wondering if they'd just lost the most important observation in human history. Tracking re-established, 7 minutes to closest approach. Then it happened, not at closest approach, but 7 minutes before. Probe 1 illuminated. Dozens of observatories saw it simultaneously. The probe, previously dark and detectable primarily through thermal emissions, suddenly brightened dramatically. Not a sudden flash, but a rapid ramp up in visible light emission. Within seconds, it had gone from magnitude 13 to magnitude 4, bright enough to see with naked eye if you knew exactly where to look. The spectrum of the light was peculiar, not thermal glow like heated metal, not reflected sunlight. This was something else. Multiple discrete wavelengths, carefully chosen, creating a light that cameras captured but that looked slightly wrong to human vision. Artificial. Intentional. The illumination lasted 43 seconds, then faded, returning the probe to its previous near invisibility. But in those 43 seconds, observatories worldwide captured high-resolution images, real images, not just fuzzy blobs. Detailed views of the object's surface, and the surface was covered in patterns, geometric designs, intricate and clearly intentional, not random markings, not impact craters or natural features. These were inscribed, engineered, deliberate. Concentric circles intersecting with straight lines. Fractal patterns repeating at multiple scales. Shapes that resembled mathematical graphs, spirals, tilings. One pattern repeated prominently, the golden ratio spiral. The same mathematical relationship that appears in nautilus shells, galaxy structures, and countless natural growth patterns, but here rendered perfectly, precisely, at a scale suggesting it was meant to be seen and recognized. Another prominent feature looked remarkably like the Arecibo message, the radio transmission Earth sent toward the globular cluster M13 in 1974. Same binary grid structure, same arrangement of elements. Had they intercepted that signal decades ago? Was this acknowledgement, proof they'd been listening? The patterns defied complete analysis in the brief window before Probe 1 reached closest approach and began receding. Teams would spend months examining the images, extracting meaning, debating interpretations. But the immediate impression was clear. This was communication, visual language, mathematics expressed in geometric form, and it was beautiful. Even in the chaos of analysis and frantic documentation, observers noted that the patterns possessed aesthetic quality beyond pure information content. They were art as much as data. Communication designed not just to convey facts, but to evoke recognition, appreciation, connection. 3:22 a.m. UTC, closest approach, 8.6 million kilometers. Probe 1 aligned precisely with predictions, passing the calculated point within meters of accuracy. For 5 minutes centered on closest approach, every sensor Earth possessed focused on that single object. The probe didn't transmit again, didn't illuminate again, just maintained its trajectory, silent and dark, while humanity's instruments documented every possible measurement. Then it was past, beginning its outbound journey, heading away from Earth on a hyperbolic trajectory that would eventually take it out of the solar system entirely. But it left data. So much data. The illumination event alone would keep researchers busy for years. The geometric patterns contained layers of information, some obvious, some subtle, some possibly still unrecognized. This was first contact, delivered not through radio dialogue, but through visual art, through mathematical beauty, through chosen revelation at a precisely calculated moment. And there were still 2 more probes approaching. The scientific community barely had time to process Probe 1's illumination event before attention shifted to the approaching Probe 2. Less than 38 hours remained until its closest approach, and expectations had fundamentally changed. This wouldn't be silent observation. The probes were engaging, communicating, revealing themselves. Analysis of Probe 1's surface patterns accelerated. Teams worked around the clock, extracting every possible bit of information from the images captured during that 43-second illumination window. The golden ratio spiral was just the beginning. Deeper examination revealed dozens of distinct mathematical concepts embedded in the geometric designs. One section depicted the periodic table, but not Earth's version. This table extended beyond our heaviest elements, showing stable islands of super-heavy elements that our physics predicted might exist, but we'd never successfully synthesized. The atomic numbers, the arrangement, the relationships, all communicated through visual pattern rather than text or symbols. Another section showed star patterns, constellations, but not as seen from Earth. These were stellar arrangements visible from a different vantage point, possibly the probe's origin system. Astrophysicists began the painstaking work of trying to match the patterns to known star fields, potentially identifying where in the galaxy these visitors came from. A third section appeared to be a timeline, events marked along a logarithmic scale with specific moments highlighted. The Big Bang marked clearly at the scale's origin, the formation of first stars, galaxy formation, and then, more recently, a series of markers that might indicate the origin civilization's development. The timeline extended to the present and slightly beyond, suggesting either projections or planned events. That last part worried some analysts. Were they seeing predictions, warnings, or simply the probe's mission schedule? The ambiguity was frustrating. Communication across species requires shared reference points, and we barely had any. Social media exploded with attempted interpretations. Every person with image editing software was analyzing the patterns, proposing meanings, connecting dots. Most of it was noise, wishful thinking, and pattern recognition gone wild. But occasionally, amateur analysts spotted details the professionals had missed. Crowdsourced analysis had real value when millions of eyes examined the same data. Meanwhile, Probe 2 continued its approach. Its trajectory took it close to Venus first, passing just 4 million kilometers from our sister planet's cloud-shrouded surface. NASA's Magellan orbiter, still operational decades past its planned mission end, captured images as Probe 2 swept through Venusian space. Venus got its own illumination event. Probe 2 lit up during its Venusian closest approach, displaying surface patterns just as Probe 1 had done at Earth. The images weren't as detailed. Magellan's cameras weren't optimized for this kind of observation, but they were clear enough to confirm different patterns. Probe 2's geometric designs weren't identical to Probe 1's, tailored content specific to each planet. What would Venus's patterns communicate? A planet with runaway greenhouse effect, surface temperatures hot enough to melt lead, crushing atmospheric pressure, but also a planet that might once have been habitable, might have had oceans in its distant past before solar evolution and carbon cycling drove it to hellish conditions. Was Probe 2 commenting on planetary evolution, warning about climate feedback loops, or simply documenting Venusian characteristics for whatever distant intelligence analyzed these reports? We'd need better images to know. Venus's patterns would remain partially mysterious until someone could enhance the Magellan data or extract more information from ground-based observations captured during the event. Probe 2's trajectory from Venus to Earth took it through interplanetary space in a graceful arc optimized by whatever propulsion system enabled its course corrections. Radar tracking showed the probe making subtle adjustments every few hours, fine-tuning its Earth approach with precision that demonstrated sophisticated navigation. December 20th, 5:37 p.m. UTC. Probe 2's closest Earth approach. This time humanity was ready. Telescopes locked on target hours early, recording systems tested and retested, backup power supplies confirmed. Nobody wanted to miss a single second of whatever Probe 2 chose to reveal. The probe cooperated. At 11 million kilometers distance, almost exactly at closest approach, it illuminated just as Probe 1 had. Same dramatic brightening, same duration, 43 seconds again, suggesting that number held significance. But the patterns were indeed different. Probe 2's designs emphasized chemistry and biology, organic molecules rendered in geometric form, amino acids, nucleotides, sugars, lipids, the building blocks of Earth-style life, shown with a completeness that suggested deep understanding of terrestrial biochemistry. DNA's double helix appeared prominently, but also RNA structures, and more complex patterns that might represent proteins or cellular mechanisms. One section showed what looked like evolutionary trees, branching patterns reminiscent of phylogenetic diagrams, showing relationships between life forms. But the details were hard to interpret. Were they showing Earth's evolutionary history as they understood it, or comparing it to life from other worlds? The branches extended in directions that didn't match known terrestrial evolution, suggesting either misunderstanding on their part or information about biology we didn't possess. Another section displayed chemical formulas, but not for naturally occurring compounds. These were complex organic molecules that looked synthetic, possibly pharmaceuticals or industrial chemicals. Some matched compounds humanity had developed. Others were completely novel. Were they offering technological information, showing what they knew we'd created, or warning about chemical dangers? The medical and biological communities went into overdrive analyzing these patterns. If aliens were communicating biochemical information, the implications for medicine, agriculture, and biotechnology could be revolutionary. Every molecule needed identification. Every pattern needed interpretation. This was treasure map for biological sciences, assuming we could read it correctly. Probe 2's patterns also included something Probe 1's hadn't: representations of technology, geometric designs that looked like circuit diagrams, mechanical systems, energy generation equipment. One section clearly depicted a spacecraft, sleek, asymmetric, covered in what might be sensor arrays or field generators. Was this a representation of 3i Atlas itself, or showing their civilization's general spacecraft design? The tech specs, if that's what they were, didn't immediately translate to human understanding. Aliens might use different physics frameworks, different engineering principles, different ways of representing technical information. An alien circuit diagram might look nothing like human schematics, even if the underlying functionality was similar. Still, researchers would pick apart every line and curve, looking for insights into how the probe builders approached technology. 43 seconds ended. Probe 2 went dark. Receded into the distance. Mission at Earth completed. Heading outward toward whatever came next in its grand tour of the solar system. 2 down. 1 to go. Probe 3, the wild card, had everyone nervous. Its trajectory remained the hardest to predict, its course corrections more frequent and larger than its siblings. Current estimates placed closest approach somewhere in the window from late December 18th to early December 20th, but the exact timing shifted with each new observation. What finally happened caught everyone by surprise. Probe 3 didn't wait for a single closest approach. Instead, it made multiple passes. Starting December 18th evening, Probe 3 began a series of orbital maneuvers that brought it through Earth's vicinity repeatedly over a 36-hour period. Not close approaches by normal standards, ranging from 15 million to 25 million kilometers, but close enough and frequent enough to suggest this probe's mission profile differed from the others. It was surveying, watching Earth from multiple angles at different times of day as our planet rotated beneath its observation platforms. Each pass lasted hours, during which Probe 3 maintained steady distance while Earth's rotation presented different hemispheres, different continents, different faces of humanity. And it illuminated during each pass, not for 43 seconds like the others, but for longer durations, several minutes each time. And the patterns changed. Each illumination event displayed different geometric designs, different mathematical concepts, different apparent messages. Pass 1 showed Earth's geography rendered in abstract form. Continents, recognizable by shape but simplified, stylized. Oceans, ice caps, major geographical features, like a map drawn by someone who'd studied Earth from space and wanted to confirm, "We know what your planet looks like." Pass 2 displayed human technology signatures, cities rendered as nodes of light, transportation networks as connecting lines, communications infrastructure as a web around the globe, satellites in orbit marked as dots. We were being shown how we appeared to observation, a species that had modified its planet's surface, that generated electromagnetic emissions, that had extended its presence into near-Earth space. Pass 3's patterns were the most intriguing and troubling. This illumination showed what looked like projections, modeling, predictions. Multiple branching pathways, each leading to different endpoints. Was this alternate futures? Possible trajectories for human civilization? Some branches led to expanded presence, more orbital infrastructure, lunar bases, Mars settlements. Others led to collapse, simplified patterns suggesting less complexity, reduced technological signatures. Was Probe 3 showing us possibilities, warning about paths to avoid, or simply modeling what their analysis suggested about humanity's potential futures? The patterns included markers, indicators of some kind, but their meaning remained maddeningly ambiguous. Pass 4, the final pass on December 20th morning, showed something unexpected. The patterns included symbols that looked almost like writing, not English, not any human alphabet, but repeated marks arranged in linear sequences that suggested language or notation. Adjacent to these symbols were mathematical expressions, possibly serving as translation keys. This was different from the pure geometric communication of earlier illuminations. This looked like an attempt at more direct linguistic exchange. The symbols appeared dozens of times throughout the patterns, always in association with specific concepts or representations, as if the probe was building a vocabulary, teaching us its language while simultaneously learning ours. After the 4th pass, Probe 3 departed. No dramatic exit, just a gradual acceleration outward as it finished whatever it came to do. Its trajectory suggested a long loop through the outer solar system, possibly targeting asteroid belt objects or Jupiter's moons on its eventual path toward interstellar space. In the aftermath of the encounters, December 21st felt like waking from a vivid dream. The probes were gone, still trackable by professional observatories, but receding, no longer immediate concerns. Earth had been examined, documented, cataloged by interstellar visitors. And now what? The data analysis would take years, possibly decades. 3 probes had each revealed hundreds of geometric patterns, thousands of distinct symbols and concepts. Every image needed examination at multiple levels, obvious meanings, subtle implications, possible interpretations we hadn't considered yet. This was a puzzle box within a puzzle box. Communication designed to work at various levels of understanding. Universities established dedicated research groups. New academic disciplines emerged overnight: xenomathematics, exolinguistics, comparative civilization studies. Funding poured in from governments and private sources. Everyone wanted to be part of decoding the messages, understanding what the probes had communicated beyond the surface level. But interpretation proved contentious. For every confident analysis, 3 contradictory interpretations appeared. Pattern recognition is a human strength, but also a weakness. We see patterns even in randomness. Distinguishing genuine meaning from projected meaning required discipline, rigor, and healthy skepticism that wasn't always present in the excitement of potential breakthrough. Religious communities grappled with theological implications. The probes represented confirmed existence of intelligence beyond Earth, not necessarily alien life in a biological sense. The probes were machines, after all, but definitely intelligence, intentionality, purposeful design. That raised questions every major religion needed to address. Some religious leaders embraced the revelation. The universe was larger and stranger than our texts explicitly described, but that didn't contradict core spiritual truths. God's creation included other minds, other expressions of consciousness. This expanded rather than diminished the divine scope. Others struggled with reconciling alien intelligence with traditions centered on humanity's special relationship with the divine. If Earth wasn't unique, if we weren't alone, did that diminish our spiritual significance? Or did it suggest God's creative abundance operated on scales even grander than previously imagined? Atheists and skeptics found themselves in interesting positions too. The probes confirmed that intelligence arose elsewhere in the universe, at least once more. That strengthened arguments that life and intelligence were natural products of physical processes, not requiring supernatural explanation. But it also raised questions about purpose and meaning that pure materialism sometimes struggled to address satisfyingly. Political implications rippled outward. The encounters had forced unprecedented international cooperation, shared observation data, coordinated analysis, joint decision-making about potential responses. Old rivalries hadn't disappeared, but they'd been temporarily transcended by shared human interest in face of cosmic visitors. Could that cooperation persist? The United Nations established a new agency, the Office of Interstellar Contact, OIC, tasked with coordinating Earth's response to any future encounters, establishing protocols for communication attempts, and serving as humanity's diplomatic interface with potential non-human intelligence. The OIC faced immediate challenges. Who speaks for Earth? By what authority? Democratic governments, the UN General Assembly, scientific institutions, religious authorities, private corporations involved in space activities. Everyone had claims to participation. Nobody had unambiguous authority. The compromise involved committees, lots of committees, scientific advisory boards, diplomatic working groups, ethics panels, communications subcommittees. bureaucratic machinery designed to ensure broad representation while remaining functional enough to respond to time-sensitive situations. Whether it would actually work in a crisis remained uncertain. Economic impacts were complex and sometimes contradictory. Stock markets had wobbled during the approach periods, but stabilized once the immediate encounters passed without incident. Defense and aerospace sectors saw investment surges. Space-related technologies attracted venture capital. Everyone wanted to develop capabilities relevant to potential future contact. But other sectors suffered. Why invest in long-term Earth-based projects when cosmic perspectives suggested different priorities? Why argue about borders and resources when the probes had implicitly demonstrated that spacefaring civilizations made territorial disputes seem petty? Economic psychology shifted in ways that traditional models struggled to predict. Tourism to observatories and dark sky sites increased dramatically. People wanted to see where the probes had been tracked, wanted to look through telescopes that had captured historic images, wanted to stand where history had been witnessed. Astronomy equipment retailers couldn't keep telescopes in stock. Everyone suddenly wanted to be an amateur astronomer. Educational priorities shifted. Science programs, especially astronomy and physics, saw enrollment increases. Students wanted to understand what had happened, wanted skills relevant to decoding alien messages or participating in future contact efforts. The probes had made space suddenly viscerally relevant in ways that abstract knowledge never had. But the encounters also generated anxiety and depression in susceptible populations. Mental health professionals reported increased cases of existential crisis, people struggling with cosmic insignificance, overwhelming feelings of smallness in face of interstellar intelligences, fear of implications they couldn't fully articulate. Support groups formed, online communities where people processed their feelings about the encounters. Some found comfort in shared experience. Others spiraled into darker patterns, convincing each other of threats and dangers that evidence didn't support. Conspiracy theories flourished in spaces where critical thinking took backseat to emotional resonance. The probes heading to other destinations continued their journeys. Probe 4 and 5 targeting Mars would arrive in February and March 2026. The red planet would get its own illumination events, its own communication. Humanity's Mars orbiters and rovers were already being positioned to capture whatever Martian-specific messages the probes revealed. Speculation about Mars messages ran wild. Would they reference ancient Martian water, the planet's dead magnetic field, the loss of atmosphere billions of years ago? Mars represented planetary death, a once habitable world reduced to frozen desert. Perhaps the probes would comment on planetary evolution, offering perspective on how worlds die and what that meant for Earth's future. Probe 6, heading to the asteroid belt, seemed destined for Ceres, the dwarf planet that represented the belt's largest body. What would probes say about asteroid resources, about planetary formation from protoplanetary disk remnants? Mining companies watched that trajectory with intense interest, wondering if alien insights might reveal resources or techniques that would transform space industry. Probe 7, the Jupiter-bound vehicle, would arrive late March, timing its approach to coincide with 3i Atlas's own Jupiter system flyby. That coordination suggested communication between probes and mothership. Were they reporting findings, coordinating observations, or simply designed with synchronized schedules for unknown reasons? Jupiter's moons, Europa, Ganymede, Callisto, Io, represented some of the solar system's most interesting targets for astrobiology. Subsurface oceans, potential habitable environments, strange chemistry in extreme conditions. Whatever messages Probe 7 illuminated near Jupiter would likely address possibilities of life in unexpected places. As January 2026 began, the initial shock and excitement settled into long-term integration. The encounters would be historical markers, before contact and after contact, dividing human history into distinct eras. But daily life continued. People still needed jobs, homes, food, relationships. Cosmic perspective didn't eliminate mundane concerns. Some people found the return to normalcy disappointing. After witnessing alien contact, how could anyone care about traffic jams or tax returns? But human nature is remarkably resilient at maintaining perspective. We live at multiple scales simultaneously: cosmic time and human time, galactic geography and personal geography. The probes were important, but so was paying rent. Education systems began incorporating the encounters into standard curriculum. Future generations would grow up learning about the probes as historical fact, rather than lived experience. What seemed revolutionary to adults in 2025 would be textbook knowledge to children born afterward. Perspective shifts across generations. Artists responded to the encounters with explosive creativity. Music, visual art, literature, film, all processing the events through cultural lenses. Some works celebrated the wonder and possibility. Others explored fear and alienation. The best captured complexity, the mixture of emotions that characterized humanity's actual experience. Science fiction saw a renaissance. Writers had been imagining first contact for over a century, and now reality had provided a test case. Some earlier scenarios proved prescient, others looked naive in hindsight. But the genre gained renewed relevance as humanity tried to imagine what might come next, what future encounters might bring. Because this wasn't ending. 3i Atlas was still out there, approaching Jupiter. The probes were still active, still conducting whatever long-term mission they'd been designed for. And beyond our solar system, in the depths of interstellar space, whoever had sent them was waiting for probe reports, waiting to see if Earth proved interesting, waiting, perhaps, to decide what came next. Were more visitors coming? Would the probe's reports trigger follow-up missions? Might humanity eventually receive actual aliens rather than just their robotic ambassadors? Or was this it? Remote sensing, distant observation, cosmic catalog entry for Earth before the builders moved on to other interests. Nobody knew. That uncertainty became the new normal, living with cosmic mystery, with questions that might not be answered in our lifetimes, with the knowledge that we'd been noticed but not yet contacted directly. Humanity was in a waiting room, existence acknowledged, but purpose still unclear. While Earth processed its 3 probe encounters, 3i Atlas continued its grand tour. The mother object, the interstellar visitor that started everything, maintained its trajectory through the outer solar system. After perihelion at the Sun, its path took it outward past Mars through the asteroid belt toward its scheduled Jupiter approach in late March 2026. Tracking 3i Atlas became routine in the months following the probe encounters. Professional observatories maintained regular observation schedules. The object was no longer front-page news. The probes had stolen that spotlight, but scientific interest remained intense. This was still an interstellar interloper, still the parent craft that deployed the probes, still potentially capable of surprises. The journey from inner solar system to Jupiter took months. Orbital mechanics don't allow shortcuts. Even with whatever advanced propulsion the probes demonstrated, covering astronomical distances requires time. 3i Atlas traveled at roughly 30 kilometers per second relative to the Sun, fast by human spacecraft standards, but still requiring patient months to traverse the gap between Mars and Jupiter orbits. During this transit, astronomers studied 3I Atlas with every available technique. Its surface features, studied extensively pre-perihelion, received renewed attention. Those geometric patterns etched across its surface, similar to what the probes later displayed, were analyzed in light of new understanding gained from probe illuminations. The patterns on 3I Atlas were more complex than those on the probes, layered with additional detail that suggested the mothercraft carried comprehensive information, like a traveling library, encoding knowledge for deployment wherever its journey took it. The probes had shown selected excerpts tailored to each target. 3I Atlas carried the complete collection. Spectroscopic analysis showed 3I Atlas was compositionally unusual, not just exotic in overall structure, but made of materials that spectroscopic databases didn't match to known solar system compositions. Elements in unexpected ratios, possible compounds that required formation conditions not naturally occurring in planetary systems. This was manufactured, assembled, built from materials sourced from where? Neutron star remnants? White dwarf atmospheres? Stellar nucleosynthesis environments we didn't understand? The object's size, roughly 800 meters at its longest dimension, made it substantial compared to typical comets or asteroids, but small compared to planetesimals or large moons. About the size of a large skyscraper laid on its side, big enough to carry significant payload, the 7 probes plus whatever other equipment and systems enabled interstellar journey, but small enough to be practical for whatever construction capabilities built it. Rotation analysis showed 3I Atlas had complex tumbling motion rather than simple spin. It rotated around multiple axes simultaneously, creating movement patterns that seemed almost chaotic, but actually followed deterministic paths through phase space. Whether this rotation was intentional, perhaps for thermal management or sensor coverage, or simply the result of momentum accumulated during construction and launch, remained unclear. February 2026 brought new activity. As 3I Atlas crossed into the outer asteroid belt, observation showed course corrections. Subtle trajectory adjustments, barely detectable, but definitely present. The object was steering itself, maintaining or modifying its path with precision beyond natural gravitational influences. This confirmed what many suspected. 3I Atlas wasn't a passive visitor, wasn't simply coasting through solar system on ballistic trajectory. It possessed propulsion, guidance, control. It was actively navigating, adjusting course to optimize whatever mission profile governed its journey. The course corrections aligned trajectory toward Jupiter with remarkable precision. Orbital calculations showed 3I Atlas was targeting a specific flyby altitude at Jupiter, approximately 2 million kilometers from cloud tops, well above radiation belts but close enough for detailed observation of the giant planet and its extensive moon system. That altitude choice was interesting. Too high for dramatic gravitational assist maneuvers, too low for simply passing through Jupiter's system en route elsewhere. The trajectory suggested observation was the priority, positioning 3I Atlas optimally for studying Jupiter while maintaining safe distance from hazards like intense radiation. Probe 7, having departed Earth's vicinity in December, was also heading toward Jupiter on converging trajectory. Its path was scheduled to bring it into Jupiter's system just days before 3I Atlas arrival. The coordination suggested planned rendezvous, or at minimum synchronized observation campaign where mothership and probe documented Jupiter simultaneously from different vantage points. As March approached, attention shifted back to 3I Atlas. Earth had been examined, documented, catalogued. Now humanity would watch as the interstellar visitor studied our solar system's largest planet. What would Jupiter reveal about the probe's mission? What observations would alien intelligence prioritize at a gas giant with complex atmospheric dynamics and a miniature planetary system of diverse moons? NASA's Juno probe, orbiting Jupiter since 2016, was still operational. Its highly elliptical orbit had degraded from originally planned trajectory, but the spacecraft remained functional and capable of observations. Mission controllers prepared observation sequences coordinating Juno's capabilities with ground-based and space-based telescope networks. The European Space Agency's JUICE spacecraft, after its detour to observe 3I Atlas at perihelion, was still years from Jupiter arrival. But other assets were available. Amateur astronomers with serious equipment could track events at Jupiter. Professional observatories had clear sightlines, and the Hubble Space Telescope, old but still powerful, dedicated time to Jupiter system observations during the approach window. March 20th, 2026. Probe 7 entered Jupiter system, crossing magnetosphere boundary at about 7 million kilometers from planet. The magnetosphere, Jupiter's magnetic field extending far into space, was first contact between probe and Jovian environment. Particle detectors on Earth-orbiting spacecraft measured disturbances as Probe 7 interacted with magnetospheric plasma. Probe 7 didn't head directly for Jupiter. Instead, its trajectory targeted Europa, the ice-covered moon with suspected subsurface ocean. Passing just 100,000 kilometers above Europa's surface, extremely close by space navigation standards, the probe conducted intensive observation of the moon that many astrobiologists considered the solar system's most promising habitat for extraterrestrial life. At closest approach to Europa, Probe 7 illuminated, same pattern as Earth encounters, dramatic brightening for 43 seconds, revealing surface covered in geometric patterns. But Europa's patterns focused on chemistry and planetary structure, representations of water ice, underlying liquid water ocean, tidal heating mechanisms that kept that ocean from freezing, chemical exchanges between surface and subsurface. One prominent pattern showed organic molecules, amino acids, simple proteins, lipids. Was Probe 7 indicating that life existed in Europa's ocean, or merely showing potential, conditions favorable for life even if biology hadn't actually arisen? The ambiguity was frustrating, but perhaps inevitable when communicating across biology and experience. After Europa, Probe 7 visited Ganymede, Jupiter's largest moon and another suspected ocean-harboring world. Then Callisto, the cratered and ancient moon orbiting in Jupiter's outer magnetosphere. Each moon received attention, observation, illumination events showing geometric patterns tailored to that world's characteristics. Io, the volcanically hyperactive moon orbiting deep in Jupiter's radiation belts, got special treatment. Probe 7's closest approach to Io, just 50,000 kilometers, revealed patterns focused on geological activity. Volcanic plumes, lava lakes, tidal forces, orbital resonances driving continuous volcanism. The patterns seemed to emphasize energy flow, heat dissipation, dynamic processes that made Io the most geologically active body in the solar system. March 26th, 3I Atlas reached its Jupiter closest approach. At 2 million kilometers altitude, exactly as trajectory calculations predicted, the mothership swept through Jupiter's system while dozens of telescopes documented every detail. And 3I Atlas illuminated. Not the brief 43-second events the probes exhibited. This was different. The mothership's illumination lasted nearly 20 minutes, a sustained, brilliant display that made the object temporarily visible to serious amateur telescopes despite the distance. The patterns 3I Atlas revealed during this extended illumination were overwhelming in complexity. layer upon layer of geometric designs, mathematical expressions, symbolic representations, everything the probes had shown individually, plus vastly more detail, additional concepts, connections between ideas that single probe patterns hadn't fully conveyed. Observers struggled to capture everything. The information density was staggering. Photography, spectroscopy, imaging across multiple wavelengths. Every technique deployed simultaneously, trying to document this cascade of communication before the illumination ended. When it finally faded, 20 minutes later, analysts faced years of work. The Jupiter illumination contained more information than all 7 probe illuminations combined. This was the comprehensive message, the full transmission, the complete package that probes had only sampled from. Preliminary analysis suggested several major themes: cosmology and origins, patterns depicting universe history from Big Bang through galaxy formation, star formation, planetary systems. Not just abstract cosmology, but specific events, the formation of heavy elements and supernovae, the assembly of planetary systems from protoplanetary disks, the conditions necessary for life-hosting worlds, biological principles, not Earth-specific biochemistry, but underlying patterns that might apply to any carbon-based life, principles of information storage, metabolism, replication, evolution, universal themes that transcended particular implementations. Technology and civilization. Representations of energy use, information processing, social organization. Patterns showing trajectories from simple tool use through industrial revolution, through spacefaring capability. Was this describing their own development, or identifying universal patterns in technological civilization emergence? Mathematics and physics. Deep dives into mathematical concepts, topology, group theory, differential equations, quantum mechanics, relativity, showing not just results but relationships, conceptual connections that linked different domains of knowledge. Purpose and destination. This was the section that generated the most intense analysis and debate. Patterns that seemed to indicate goals, intentions, trajectories. Where 3I Atlas came from, a region toward galactic center, though specific star system remained ambiguous. Where it was going, continuing through and eventually out of solar system, heading toward somewhere. Another star system? Back toward origin. The patterns suggested direction but not definite destination. And then there were patterns nobody could interpret. Symbols and structures that didn't connect to anything in human knowledge base. Were these concepts we simply didn't understand yet? Or communication meant for intelligences more advanced than current humanity? Information we might grow into understanding with further development. After the illumination, 3I Atlas continued outward. Its trajectory would take it past Saturn's orbit by mid-2027, Uranus by 2028, eventually reaching solar system's edge and transitioning back to interstellar space. Unless it did something unexpected, further course corrections, additional communications, new deployments, the main encounter phase was ending. The probes had visited targets throughout the solar system. 3I Atlas had revealed its comprehensive message at Jupiter. What remained was analysis, interpretation, integration. Years of work extracting meaning from geometric patterns and mathematical symbols. But one question dominated discussion. Would there be follow-up? The probes and mothership had studied humanity, documented our civilization, assessed our capabilities and characteristics. They'd attempted communication through mathematical and visual language. They'd revealed information about themselves, their mission, their perspective. And then they'd continued their journey, receding into space, heading toward exits from solar system. Was this farewell? Would future encounters happen? Might whoever sent these robotic ambassadors send something more, actual representatives, or more probes, or invitations to communication through interstellar messaging? Nobody knew. The visitors had spoken, but hadn't yet given clear indication of what came next. Humanity was left with gifts, knowledge, perspective, cosmic context, but without definitive answers about future contact or the role Earth might play in larger galactic community. A year after the encounters, December 2026, Earth had settled into uncomfortable equilibrium. The initial excitement had faded. The probes were long gone, receding toward interstellar space. 3I Atlas was beyond Saturn orbit, diminishing to faintness even for large telescopes. The visitors had come and gone, leaving humanity changed but unclear about the implications of that change. The academic analysis continued, of course. Universities and research institutions employed hundreds of specialists working full-time on interpreting the probe and mothership illuminations. Progress came in increments, a geometric pattern decoded here, a mathematical reference understood there. But the comprehensive meaning, the full message, remained elusive. Some researchers believed they'd extracted core concepts. The visitors were from an ancient civilization, billions of years ahead of humanity in development. They explored the galaxy through probes like 3I Atlas, mapping worlds, cataloging species, documenting the diversity of consciousness and intelligence throughout cosmic space. Earth was being added to their database. Humanity recorded as one more instance of intelligence arising from natural processes. Others argued for more active interpretation. The patterns weren't just documentation, they contained teachings, mathematical concepts that could advance human physics, biological principles that might revolutionize medicine, technological hints embedded in geometric designs. The visitors were offering knowledge, gift-wrapping cosmic insights in visual form for species ready to receive them. A third interpretation emphasized warning. Some patterns, when viewed through pessimistic lens, suggested caution about trajectories humanity was following. Environmental degradation, resource depletion, existential risks from advanced technology. Perhaps the visitors were highlighting paths that led to civilizational collapse, using their own history or observations of failed civilizations to warn newcomers like humanity about common pitfalls. The truth, probably elements of all three, plus aspects nobody had correctly interpreted yet. Communication across species requires shared context, and human-alien overlap might be limited. The visitors communicated what they could, using mathematics and visual patterns as common ground, but full understanding might require development humanity hadn't achieved yet, perspective we'd need centuries more experience to acquire. Religious and philosophical communities continued grappling with cosmic implications. Some traditions adapted smoothly, incorporating alien existence into existing theological frameworks. Others struggled, experiencing schisms between conservative factions denying significance and progressive wings embracing expanded cosmology. New religious movements emerged, of course, cults proclaiming the probes as divine messengers or demons or tests, groups believing the visitors would return to initiate chosen believers into galactic community. Apocalyptic sects convinced the encounters presaged imminent transformation or destruction. Most were harmless, communities finding meaning through shared belief. A few were dangerous, authoritarian structures exploiting uncertainty for control. Political impacts proved surprisingly limited. Initial cooperation between nations didn't translate into lasting institutional change. The UN Office of Interstellar Contact existed, employed staff, published reports, but funding remained modest. Political attention drifted elsewhere. Humanity's traditional concerns, borders, economics, power dynamics, reasserted dominance once immediate alien presence departed. Some criticized this as short-sighted. Cosmic perspective should transform politics, should make nationalist competition and resource hoarding seem absurd. We'd been visited by intelligence that made our civilization look like children. How could anyone continue business-as-usual politics after that? But others argued this was simply realism. The visitors didn't solve human problems. They documented our existence, communicated briefly, then left. Daily challenges of governance, economics, social organization remained. People still needed food, shelter, security. Cosmic context didn't eliminate immediate needs. Perhaps future encounters would force transformation. If more probes arrived, if direct communication developed, if aliens offered or demanded specific changes in human behavior, then politics might shift dramatically. But passive observation followed by departure didn't create that pressure. It left humanity free to continue existing patterns, for better or worse. Economic impacts were more substantial. Space industry boomed. Every nation with resources invested in expanded space capabilities. Satellites, space stations, lunar bases, Mars missions all received increased funding and political support. The logic was clear. Future contact might require space-based capabilities, and Earth wanted to present itself as spacefaring civilization worthy of attention. Private companies raced to develop advanced propulsion systems. If aliens could do interstellar travel, humanity should at least manage efficient solar system travel. Breakthrough propulsion concepts received serious investment. Nuclear pulse propulsion, fusion drives, even speculative concepts like field propulsion that probe observations suggested might be possible. Tourism expanded beyond Earth orbit. Lunar hotels opened for wealthy visitors. Plans for Mars tourism became serious business proposals. People wanted to stand on other worlds, to see Earth from cosmic vantage points, to participate in humanity's expansion beyond its home planet, even if just as tourists. Education systems continued evolving. Students who'd witnessed the encounters as children would become adults shaped by that experience. They'd never known world without confirmed alien intelligence. They'd grown up with cosmic perspective as baseline rather than revelation. How would that shape their priorities, their values, their approaches to life's fundamental questions? Too early to tell definitively, but preliminary indications suggested subtle shifts. Less nationalism, more cosmopolitan outlook, more interest in science and philosophy, less in purely local concerns. Greater comfort with uncertainty and ambiguity. These were generalizations with many exceptions, but trends seemed real. The arts continued processing encounter experiences. Music composed inspired by probe illumination patterns. Visual art incorporating geometric designs from alien communications. Literature exploring themes of contact, communication across difference, cosmic loneliness and connection. Films and interactive media letting people experience fictional versions of what first contact might have been, could be in future, meant for humanity's development. Science fiction particularly thrived. Writers no longer needed to convince audiences that alien contact was plausible. It had happened. The challenge became imagining what came next. Would more probes arrive? Would we eventually meet the probe builders? Would humanity develop interstellar travel and visit other worlds ourselves? Some stories were optimistic, envisioning humanity joining galactic community, learning from elder civilizations, contributing our own unique perspectives and capabilities. Others were pessimistic, warning that contact might bring subjugation, that advanced civilizations might not value newcomers, that humanity might discover it was prey rather than partner in cosmic ecology. The best stories avoided simple optimism or pessimism, recognizing that reality would probably prove complex, challenging, rewarding and difficult simultaneously. Just as the actual encounter had been neither utopian revelation nor apocalyptic disaster, but strange and transformative in ways that defied simple emotional response. By December 2027, second anniversary of the probe encounters, commemoration events were held worldwide. Remembering those days when 3 objects swept past Earth, when alien intelligence revealed itself through geometric patterns and mathematical beauty, when humanity briefly glimpsed itself through extraterrestrial eyes. The commemorations mixed celebration with frustration. Yes, we'd experienced something extraordinary, but where did we go from here? The visitors were gone. No follow-up contact had occurred. The probes sent to Mars and asteroids and Jupiter moons had completed their missions and departed. 3I Atlas was approaching Uranus orbit, heading inexorably toward eventual exit from solar system. Were we just waiting? Waiting for aliens to return, to initiate deeper contact, to explain their intentions? Or should humanity take initiative? Should we launch our own interstellar probes toward stars where visitors might have originated? Should we broadcast messages toward galactic center, attempting communication with whoever sent 3I Atlas? The debate continued without resolution. Conservative voices urged caution. Don't announce ourselves more than we already have. Don't invite attention from intelligences whose motives we don't understand. Progressive voices argued for active engagement. Silence was refusal to participate in cosmic conversation, was rejection of connection with the wider universe. Meanwhile, observatories continued tracking 3I Atlas, even as it faded toward invisibility, exceeded capabilities of smaller telescopes, entered regions of space where only the most sensitive instruments could follow its progress. Some researchers would maintain watch for years, decades, documenting the object's entire transit through solar system and eventual return to interstellar space. In 2031, when 3I Atlas crossed Neptune orbit, it would be at the edge of conventional planetary system. In 2035 to 2040, it would traverse the scattered disk and Kuiper belt, regions of icy bodies and dwarf planets at solar system's frontier. In 2050, it would reach the heliopause, boundary where solar wind yields to interstellar medium, and then, assuming no further surprises, it would be gone, returned to the dark between stars, continuing whatever billion-year journey it was on. The probes would follow similar trajectories, eventually. Each would escape solar system's gravitational influence, become interstellar travelers themselves. Humanity's solar system would be richer for their visit. Knowledge gained, perspectives shifted, questions raised that would occupy scientists and philosophers for generations. But physically, the visitors would leave nothing behind except memories and data. Perhaps that was the point. Perhaps truly advanced civilizations didn't leave monuments, didn't terraform or colonize or impose themselves on visited systems. Perhaps they simply observed, documented, communicated where possible, then moved on. Cosmic naturalists, studying life's diversity without disturbing the specimens. Or perhaps we were being tested, observed to determine if humanity merited more direct contact, deeper engagement, invitation into whatever community existed among spacefaring intelligences. Perhaps the probes were preliminary survey, and real contact would follow once we demonstrated sufficient development, sufficient wisdom, sufficient readiness for cosmic citizenship. Or perhaps, hardest to accept, but possibly true, we simply weren't that interesting. Earth might be one survey stop among millions. Humanity might be ordinary, unremarkable, one more instance of tool-using intelligence arising on wet planet around yellow star. The visitors might have moved on without special concern, adding us to their catalog before continuing to more interesting targets. Not knowing was perhaps the most challenging aspect. Uncertainty about whether contact would continue, whether meaning existed beyond the bare fact of encounter, whether humanity's cosmic significance exceeded our own self-importance. But uncertainty was also liberation. Not knowing meant possibilities remained open. The future wasn't predetermined by alien judgment or cosmic role assignment. Humanity retained agency, could choose its own path, could decide what kind of civilization to become, regardless of whether anyone from distant stars was watching or caring. The encounters had given us gift of perspective. We'd seen ourselves as aliens might see us, technologically adolescent, ecologically reckless, socially fractured, but also creative, curious, capable of growth. We'd glimpsed the universe as grander and stranger than our isolated perspective suggested. We'd learned that intelligence existed beyond our world, that we weren't unique or alone in cosmic consideration. What we did with that knowledge was up to us. The aliens had visited, observed, departed. They'd offered communication through mathematical beauty and geometric art. They'd documented our moment in cosmic history, but they hadn't solved our problems, hadn't given us destiny, hadn't removed responsibility for our own future. We were still the authors of our story, just writing now, with awareness that others were writing their stories too, across the vast expanse of space and time. Connected not through direct interaction, but through shared participation in cosmos that produced consciousness, intelligence, meaning. The wait continued, for some future encounter, or for none, for answers, or for acceptance that some questions lacked definite answers, for transformation, or for integration of extraordinary into ordinary fabric of existence. And overhead, invisible to human eyes but tracked by patient telescopes, 3-Eye Atlas continued outward, silent messenger from deep past, bearing record of brief meeting between two intelligences separated by evolution, experience, and immeasurable temporal and spatial distance, heading back toward the stars, carrying data from its solar system survey toward whatever civilization would eventually receive and interpret that information. Humanity watched it go, and wondered, and waited, and lived.